Hi, this is ESPLANA. Good afternoon. Today we are going to tackle about the coding schemes. So, a coding schemes is a standard which tells the user's machine which character represents which set of bytes. And specifying the coding scheme use is very important, as without it, the machine could interpret the given bytes as a different characters than intended. But first of all, what are codes? In programming or communication and information processing, code is a system of rules to convert information, such as a letter, word, sound, image, or gestures, into another form, sometimes shortened or secret. For communication, it is through a communication channel. In storage, it is in a storage medium. So we can see here that a coding scheme is a set of codes defined by words or phrases that is assigned to categorize a certain data. There are three coding scheme. First is the ASCII, abbreviation for American Standard Code for Information Interchange. They call it ASCII as a pronunciation. And in the next slide, we could see the table for the ASCII. And you can see that each alphabet, lower and uppercase, numeric values and special characters are actually in there, and actually it is represented by a 7-bit binary number. It is not in the table, but we have the decimal number. Each letters or each elements there has a corresponding decimal number, and that decimal number is actually could be converted into a binary number. We will have to add a link here, a video link, so we could learn how to convert a decimal number of a certain element, like the big letter A, which is the decimal number 65, and how to convert it into a binary number, a string of 7 zeros or ones. And a bit is the smallest unit of data in a computer. And actually, this ASCII or ASCII, actually they have a former version, the ASCII 7. It was actually improved to ASCII 8 because the representation would be now 8-bit binary number. And for this ASCII 7, there are 127 combinations and unique symbols that they could be capable of. And then second is the EBCDIC, or the EBCDIC, abbreviation for Extended Binary Coded Decimal Interchange Code. It is developed by the company IBM, or the Internet Business Machines. They develop it for the company's systems or larger systems. Because again, this EBCDIC coding system is mainly used in a mainframe computers, or the large computers, that could cater a whole room. Anyway, for the EBCDIC, 256 possible characters that it can cater. Letters of the alphabet, the lower and uppercase, numerals, punctuation marks, and the special characters, and many other. You can see that on the table on the next slide. And also, the EBCDIC is much more improved, like the ASCII 8. because it has 8 bits or 8-bit code. 4 bits for the zone and 4 bits for the digit. And when we say 8-bit codes, it can allow 256 combinations and 256 unique symbols. Yeah, it is much more improved than the first one, the ASCII. Well, the third one is the Unicode. That's for universal code. This coding scheme supports the world's most world's languages, and is becoming the internet standard because it represents more than 65,000 characters and symbols. As I said earlier, the world's most languages, even the complicated language like the Chinese and Japanese, they have different letters and different characters for their language. But still, the Unicode could cater that. And that's why the Unicode is becoming the internet standard as of today. And for the Unicode, it is much more improved. I mean, it is in the highest level or perfection because it has 32 bits. And it can cater up to 4 billion combinations. Just like the ASCII 8, the improved ASCII, it is implemented by a character coding and now the commonly used coding scheme as of today. And also, not just 32 bits, it could use 8 to 32 bits per code. So the table is in the next slide. So yeah, as of today, we have here different terms. First, the binary code. We could use this term so that we could really understand how these coding schemes work. So binary code is the simplest form for computer code and programming data, often associated with machine code in the binary sets, can be combined as well to form a raw code, which is interpreted by a computer and other piece of hardware. Binary numbering or binary number system. Numbering system that represent numeric values using 2 unique digits, only 1 and 2. So binary, bi means 2. 0 and 1, I'm sorry. Next is the binary file, type of computer file that stores binary data that may contain the formatted and unformatted data that is encoded within binary format. Binary digit in the form of bit, the smallest unit of information in a computer. A computer often classified as to how many bits it can process at one time and by the number of bits in a memory address. So let's go ahead with integer in computer. So an integer is a datum of integral data, a data type that represents some range of mathematical integers. Integral data types may be of different sizes and may or may not be allowed to contain negative values. So yeah, integers are commonly represented in a computer as a group of binary digits or bits. The size of grouping varies, so the set of integer sizes available varies between different types of computers. Computer hardware nearly always provides a way to represent a processor register or a memory address as an integer. If you could see your computers, you could see in the settings if the computer can does have 32 bit of memory or 64 bit of CPU or the central processing unit. And yeah, an integer value is typically specified in the source code of a program as a sequence of digits, optionally prefixed with a sign, plus or minus. Some programming languages allow other notations, such as hexadecimal or base 16 or octal, base 8. The internal representation of this datum is way the value is stored in the computer's memory, while byte is the basic unit of information in computer storage and processing. The term octets always refers to the 8-bit quantity. It is mostly used in the field of computer networking, where computers with different byte widths might have to communicate. Word in computing, the word is a natural unit of data used by a particular processor design. A word is a fixed size piece of data handled as a unit by the instruction set of a hardware of the processor. Short integer can represent a whole number that may take less storage while having a smaller range compared with a standard integer on the same machine. Long integer can represent a whole integer that the range is greater than or equal to that of standard integer on the same machine. And I think that's it for my part. Thank you.
Next, we are going to tackle about binary, octal, decimal, hexadecimal systems. Computer systems regularly use numeral systems of bases other than 10. Base 2, binary, base 8, octal, base 16, hexadecimal numeral systems are used because designing a computer system is simpler in this manner than for other bases. Binary numbers are the core of all computer operations. Unlike a decimal number, which has 10 digits, a binary number is made up of only 2 digits, ones and zeros. It's very easy to represent binary values in electrical circuits and computer systems. A high voltage can be used for 1 and a low voltage for 0. A single value such as a 1 or 0 is called a bit. So here are the operations on binary numbers. So first we have here the decimal. For example, 329 for the base of 10 or decimal. So at the table, we can see that our base is 10. So in the first table, we can see a 1 because 10 to the power of 0 is equals to 1. In the second row of table, you can see 10, which is because 10 to the power of 1 is 10. To the third column or row of the table, we have 100, which is because 10 to the power of 2 is 100. So if you're wondering why 3 is in 100, it is because 3 times 100 is 300, and it is in the 100 form. Same goes to 2 and 9. 2 times 10 is 20. So it is in the 10th form. While 9 times 1 is equals to 9, which is in the ones form. So in total, we will have a answer of 329. So that is how you solve for the decimal. So the next operation is binary. So suppose the number of 101 and our base is 2 or binary. So just like in the decimal, table, we will have 1, 2, and 4, which is because 2 to the power of 0 is 1, and 2 to the power of 1 is 2, then 2 to the power of 2 is 4. 1 times 4 is equals to 4. 0 times 2 is equals to 0. 1 times 1 is equals to 1. So in total, we will have a answer of 5, which is 101 or 101 in binary is 5 in the decimal. So the next thing that we have here is addition of binary numbers. To add binary numbers, let us always remember the following magic table, because this magic table is very important and useful in solving and adding the binary numbers. So first, we have here 0 plus 0 is equals to 0. Second, 1 plus 0 is equals to 1. 0 plus 1 is equals to 1. And 1 plus 1 is equals to 10. And lastly, 1 plus 1 plus 1 is equals to 11. So here is an example of adding binary numbers. So the example is we have the number of 0111 plus 0110. So first, we have to solve the first column, which is 1 plus 0. 1 plus 0 in magic table is 1. Next, in the second column, we have 1 plus 1. 1 plus 1 in the magic table is 10, so we carry the 1. Then the next, in the third column, 1 plus 1 plus 1 is equals to 11 based on the magic table. So we have to carry the 1 again in the fourth column. So in the fourth column, we have 1 plus 0 plus 0. So basically, if we add it, the answer is 1. So in equal, or in total, we have an answer of 1101. So if you're wondering what are the numbers beside it, it is a numbers based on decimals or decimal. In our example, we have a basis of 1 and 0. So in order to get the decimal form, we have to solve for this thing in the right side, which is 1 to the power of 0 is equals to 1. Then 1 to the power of 1 is 2. 1 to the power of 2 is equals to 4. 0 to the power of 3 is 0. So to add that up, we have here 4 plus 2 plus 1, so equals 7. So the 0111 in decimals is 7. Next, we will solve for the second column, which has 0110. So to solve this and to have the decimal form of it, we will have 0 to the power of 0 is equals to 0. 1 to the power of 1 is equals to 2. 1 to the power of 2 is equals to 4. 0 to the power of 3 is equals to 0. So in total, we have 4 plus 2. And in total, we have the answer of 6. So 0110 in decimal is 6. So to add up all, 7 plus 6 is equals to 13. So our answer in this example is 13 or 1101. So the next operation is subtraction of binary numbers. To subtract binary numbers, then let us use the following magic table. Just like in addition, we also have magic table in subtraction. So 1 minus 1 is equals to 0. 0 minus 0 is equals to 0. 1 minus 0 is equals to 1. 0 minus 1 is equals to 1. But carry is required. 10 minus 1 is equals to 1. For example, we have here the example of 10111 minus 10101. So in total, we have an answer of 00010. So first, we have to solve for the first column. 1 minus 1 is equals to 0. 1 minus 0 is equals to 1. 1 minus 1 is equals to 0. 0 minus 0 is equals to 0. Then lastly, 1 minus 1 is equals to 0. So here's the answer, 0, 0, 0, 1, 0. Just like in addition, in the right side of it, we have the decimal form. And this is also the same with addition on how to get the decimal form of it. So in total, in the first column, we have 16 plus 4 plus 2 plus 1. So equals to 23. So the decimal form of 10111 is 23. Next, we have in total of 16 plus 4 plus 1 is equals to 21. So the 10101 in decimal form is 21. To subtract it, 23 minus 21 is equals to 2. So the answer of this example is 00010 or 2 in decimal form. Multiplication of binary numbers. To multiply binary numbers, we will do the same process as decimals. For example, we have here 0101 times 1011. To find the answer, we have to multiply 1 times 1 is equals to 1. 1 times 0 is equals to 0. 1 times 1 is equals to 1. And 1 times 0 is equals to 0. So next, 1 times 1 is equals to 1. 1 times 0 is equals to 0. 1 times 1 is equals to 1. 1 times 0 is equals to 0. Next, 0 times 1 is equals to 0. 0 times 0 is equals to 0. 0 times 1 is equals to 0. And 0 times 0 is equals to 0. Next, 1 times 1 is equals to 1. 1 times 0 is equals to 0. 1 times 1 is equals to 1. And 1 times 0 is equals to 0. So in total, we have to add it up to have the answer. So 1, we bring down the 1. 1 plus 0, so it is 1. 1 plus 0 is 1. 0 plus 1 plus 0 plus 1 is 10. We have to carry the 1 to the next column. So 1 plus 0 plus 0 plus 0 is equals to 1. Next, 0 plus 1 is 1. Then we bring down the 0. So the answer here is 110111. It's like in addition and subtraction, we also have here the decimal form. So 0101 in decimal is 4 plus 1 and it is equals to 5. 1011 in decimal is 8 plus 2 plus 1. In equal, we have 11. So 5 times 11, the answer is 55. So the answer of this example is 110111 or 55 in decimal. And the last operation is division of binary numbers. In dividing binary numbers, we will use the same process as in decimals. So our example here is 11 divide 100111. So the first thing we will do is divide 11 to 10. So 11 divide 10 is equals to 0. So we have to put the 0 above, and then 0 times 11 is equals to 11. So we will put the 11 below the 10, and then we subtract it. So 0 minus 1 is equals to 1. Then 1 subtracted by 1 is 0. So 11 cannot be divided with 1. So we have to borrow from the next digit, which is 0. So bring down 0, and then again we will divide 11 divide 10. So the answer is 0 again. So 0 times 11 is 11. So we will subtract it again to 0 minus 1 is equals to 1. 1 minus 1 is equals to 0. So 11 divided by 1 is cannot be divided, so we will borrow from the next digit again. So we will bring down the 1. So 11 divided by 11 is equals to 1. So 1 times 11 is equals to 11. So next, we will subtract it. 1 minus 1 is equals to 0. 1 minus 1 is equals to 0. So 0 cannot be divided by 11. So we will borrow 2 digits. We will bring down the 2 1. So it will be 11 divided by 11 is equals to 1. Then 1 times 11 is equals to 11. So our remainder here is 0, because if we subtract 1 minus 1, 0. Then 1 minus 1, 0. So our remainder is 0. Then our answer in this example is 0, 0, 1, 1, 0, 1. So that is how you divide binary numbers. And that is all our presentation for today. Thank you for watching and listening.